this video, I would like to share with you a hot topic in urban climatology, that is urban heat island, usually represented as UHI. The high rate of urbanization has resulted in drastic demographic, economic, land use, and climate modifications in the urban regions. This development leads to the formation of urban heat islands, the phenomenon whereby urban regions experience warmer temperatures than their rural surroundings. An urban heat island is a phenomenon of elevated air temperature within the urban region with respect to adjoining rural areas. Urban heat island can be classified into three. First one, surface urban heat island exists at the surface and is remotely sensed. It is observed by using thermal infrared data that allow to retrieve land surface temperatures. Second one, subsurface heat island. These are formed by at different layers of soil beneath the earth's surface. Third one, atmospheric heat island. These are formed where there is a difference between the air temperatures of urban and rural areas. These are further subdivided into two types. First one, boundary layer urban heat islands. Start from the rooftop and treetop level and extend up to the point where urban landscapes no longer influence the atmosphere. Second one, canopy layer urban heat islands exist in the layer of air where people live, from the ground to below the tops of trees and trees. Major factors that influence UHI are: first one, thermal property of the building material used. Properties of urban materials, in particular solar reflectance, thermal emissivity, and heat capacity, influence urban heat island development as they determine how the sun's energy is reflected, emitted, and absorbed. Second, street geometry. An additional factor that influences urban heat island development, particularly at night, is urban geometry, which refers to the dimensions and spacing of buildings within a city. Urban geometry influences wind flow, energy absorption, and a given surface ability to emit long-wave radiation back to space. Third one, vegetation. In rural areas, vegetation and open land typically dominate the landscape. Trees and vegetation provide shade, which helps lower surface temperatures. Soil moisture. As cities develop, more surfaces are ploughed or covered with buildings. The change in groundwater results in less shade and moisture to keep urban area cool. Built-up areas evaporate less water, which contributes to elevated surface and air temperatures. Energy consumption. Elevated summertime temperature in cities increases energy demand for cooling, which further enhances UHI intensity. Pollution. Higher temperatures can increase energy demand, which generally causes higher level of air pollution and greenhouse gas emissions. These pollutions are harmful to human health and contribute to complex air quality problems such as acid rain, in addition to UHI. Anthropogenic heat contributes to atmospheric heat islands and refers to heat produced by human activities. Now, strategies to reduce urban heat islands. First one, green vegetation. Increasing the amount of vegetation is one of the most effective strategies to mitigate the effect of the urban microclimate. Trees have a direct effect on the heat island effect by their evapotranspiration. Temperature usually decreases by zero point 0.6 Kelvin for each 10% addition of vegetation. Second, shade trees. Shade trees help to cut down the temperature by evapotranspiration process. The principal role of shade tree is that sunlight is intercepted by it, keeping the buildings comparatively cooler. Water bodies. As the heat absorption capacity of water is high, it will help to reduce the urban temperature. Next one, high albedo roofing material and green roofs. Albedo. Albedo is a measure of how much light that hits a surface is reflected without being absorbed. Something that appears white reflects more of the light that hits it and has a high albedo, while something that looks dark absorbs most of the light that hits it, indicating a low albedo. Now, high albedo roofing materials. Light colored roofs with similar insulation properties do not get warmer significantly by reflecting solar radiation. So the choice of roofing color can contribute to temperature reduction. Green roofs. Green roofs absorb heat and filter the air, keeping the temperature lower. Green roofs help to delay the runoff duration, which will keep the cities cooler for a long period. High albedo pavements. More solar radiation could be reflected if the road and highway pavements were of high albedo materials. Pervious pavement. Impervious pavement does not allow water to infiltrate, and cooling effect by evapotranspiration is not significant in this case. If the impermeable pavement are replaced with pervious pavement, which will help to keep the pavements cool and directly affecting the temperature. Urban planning. Proper urban planning can also play a vital role in the mitigation of UHI effect. If there is sufficient amount of free space and channel to circulate the wind, it helps to minimize the effect of the urban microclimate. So, proper planning of the building environment and selection of raw materials is necessary to reduce the problem of excessive actual heat loads within building environment. Even though the development demand that determine the choice of the path upset the natural harmony, conservation of natural resources is the easiest and appropriate method to reduce the heat island effect. Efforts should be made for the sustainable development by protecting our nature. Thank you.